In this program, we have two functions. A function mi takes a integer array and number of elements in it as arguments and returns index of the largest valued element. We have another function selectionSort, which also takes a 1D array and number of elements in it, and then sorts the array elements by calling the mi function. That is, first time it calls the mi function and sends the number of elements as n. Thus, it returns the largest element index out of the n elements that is assigned to j, and then j, a of j and a of n minus 1 minus j, that is, they get exchanged. In the next iteration, same mi function is called, and this time n minus 1 elements. So we want to find out the largest element index out of the n minus 1 elements. Already the largest element is available at the end of the array. So out of the remaining n minus 1 elements, which is the largest? Its index we wanted. So thus we are again calling the function mi, but we are sending the number of elements as n minus 1. Whatever the function mi returns, that is assigned to j. That element, that is a of j element, and the second element from the last, they get exchanged like this. Second largest goes to second element from the last. Like this, we will be selecting the largest elements and we will be putting them at the end of the array. Like this, if we for n minus 1 times, the array elements gets sorted. In the main, we have declared a 1D integer array x, and data is read into this array, and then selectionSort function is called, and once you come out from the function, the array elements will be printed by writing another for loop. The following slides will demonstrate how the for loop of the main, which reads the data into the array x, will be demonstrated. Let us assume that the function selectionSort is called from the main. We are sending the array x as an argument, and n, the number of elements 5, as second argument for this function. In the following slides, we will try to simulate how this function works. Now, the control is in the function selectionSort. Here n value is 5, I value is 0, that is first time when the for loop is executed, that is I value becomes 0, and then the statement j is equal to mi, that statement will be executed. That is, the function mi is called. For this function, we are sending n minus I, that is 5 minus 0, 5 we are sending as the second argument for the function mi. That is, we are sending the whole array and 5 as the second argument, indicating that the mi function has to take 5 elements and return the index of the largest element out of these 5 elements. Let us see how this mi function works. The for loop inside the mi function will be executed. Finally, the id value becomes 3. That is the index of the largest valued element out of the 5 elements. So, that 3 value will be returned from this function mi. Now, the control comes to selection sort function. Thus, j value becomes 3. That is, the value return 5, the mi function. The elements a of j and a of n minus 1 minus I, they gets exchanged. That is 45 and 32 gets exchanged. That is, largest is now kept at the last element. That is, we have selected the largest element and that is now kept at the end. Now, the for loop I value becomes 1. Again, the function mi is called. This time, the whole array we are sending. However, the second argument we are sending as n minus I, that is 5 minus 1, 4, we are sending to the function mi. That is, we are asking the mi function to return the index of the largest valued element out of the first 4 elements only. Thus, we are sending 4. Thus, the control goes to the function mi. Now, the program control is in the mi function. So, this function is supposed to return the index of the largest valued element out of the 4 elements. Remember, we are sending 4 from the function selection sort now. Thus, out of the first 4 elements, this function is supposed to return the index of the largest valued element. The for loop finds the index of the largest valued element. The same will be returned. Index of the largest value element is 2. The function mi returns 2 to the selection sort function. Now, the program control returns to selection sort function. The mi function returns 2, thus j value becomes 2. Now, a of j, that is 41, and a of n minus 1 minus I, currently I value is 1, thus n minus 1 minus I value is 3, that is 32. Now 41 and 32 gets exchanged. Now I value will be incremented by 1, thus I value becomes 2. Then the function mi is called once more. However, this time we are sending n minus 2, that is 3, as a second argument for the function mi. That is, we wanted from this function the index of the largest element out of the first 3 elements only. Thus, we are sending 3. Thus, the program control goes to the function mi. Now, the control is in the function mi. The second argument is 3. That is, n value here in this function is 3. That is, we are interested to find out the index of the largest valued element out of the first 3 elements. Thus, the for loop works and tries to find out the index of the largest valued element. The same will be returned. in the function, the id value becomes 2. That is the index of the largest value element value becomes 2. The same will be returned from the function. Now the control is in the function selection sort. The function mi returns 2, thus j value becomes 2. Now the elements a of j and a of n minus 1 minus I, they gets exchanged. Incidentally, 32 will be in its position itself in this data. I value will be incremented by 1, that it becomes 3. Then the function mi will be called again. This time the second argument to the function mi becomes 2, that is n minus 3, that is 5 minus 3, it becomes 2. That is, we are asking the mi function to return the index of the first two elements, that is largest of the first two elements of the array. Now the control is in the function mi. The second argument for this is 2. That is, we are interested to find out the index of the largest value element out of the first two elements. The for loop finds out, and incidentally it is identified to be 0. 0 will be returned to the selection sort function. Now the control is in the selection sort function. The mi function returns 0, thus j value becomes 0. The elements a of j and a of n minus 1 minus j, that is a0, j value is 0, 21, and n minus 1 minus I, that is 3, 1, that is 3, 21 and 3, they gets exchanged. By this time, you might have observed that the array elements got exchanged, or rather say sorted. Now the control comes out from the selection sort function. The control now in the main program, and the last for loop in the main program will print the sorted elements of the array. The following slides will demonstrate how the selection sorting takes place. That is, first the index of the element will be found, that may be smallest element or largest element, it doesn't matter, and that will be exchanged with the either first element or the last element of the array. Like this it will be proceeded. We will be showing only few iterations of the data or this algorithm. Here the bar heights indicates the values. You can see the simulation. if we see the algorithm, when we call the function mi, first time we have sent n elements. So by spending n minus 1 comparisons, it has returned the index of the largest valid element. Next time the function mi is called, we are sending n minus 1 as the second argument. Thus, it requires n minus 2 comparisons to return the index of the largest element out of the n minus 1 elements. Like this, last time when the function mi is called, we have sent 2. Thus, it requires only one comparison to return the index of the largest valued element. Like this algorithm in total requires n minus 1 plus n minus 2 etc. 1 number of comparisons. If we sum, it becomes n into n plus 1 by 2. Thus, its order is also quadratic order. Sorry, the sum of n minus 1 plus n minus 2 etc. 1 is n into n minus 1 by 2, not n into n plus 1 by 2. Of course, the order is still second order only, that is quadratic order. I am sure that you remember the bubble sorting complexity is also same, that is also second order complexity. Thus, this algorithm also second order complexity algorithm.